Hello everybody, welcome into another lesson. So today we are going to simplify algebraic fractions. Well, what you have to do to simplify is you have to factor out the numerator and the denominator. So let's go ahead and do that here. The numerator, we have a common 2 we can factor out. We have 2x plus 2y all over 4. We have a common 2 we could factor out. You'd have 2 times the quantity of x plus y all over 4. Well, we know between the numerator and denominator you could factor out a common 2, and if you do that you just get x plus y over 2. And that would be how you simplify this fraction, would be x plus y over 2. And I got more examples here. Let's see, we got 12m minus 15n over 9. 12m minus 15n over 9. Well, let's start with the numerator. What's the common factor of 12m and 15n? Definitely a 3. You definitely 3 factors out, so then you'd have 3 times the quantity of 4m, because 3 times 4m is 12m, minus, then you'd have 5n, because 3 times 5n is 15n. That doesn't factor any further. You have that over 9. Well, between the numerator and denominator are 3 factors out. You factor the 3 out, you're going to get 4m minus 5n over 3. And that's as much as you can factor it. So when you simplify this, you would get 4m minus 5n over 3. Alright. Now, we have 5a minus 10 all over a minus 2. Well, now we have a variable in the denominator. Here's the thing about when you have variables in the denominator, okay? There are what's called restrictions on this fraction. The restriction is if there's any value of the variable that makes the denominator 0, it can't be that value. So you take your denominator of a minus 2, you're going to set that equal to 0. Take your a minus 2, set that equal to 0. Well, a would equal 2. So really a cannot equal 2. That's your restriction. If a equals 2, you have a denominator of 0, which makes the expression undefined. So a cannot equal 2. That's going to be a restriction on this. A cannot equal 2. But that'll come into play when we go to add, subtract, and multiply and divide and solve these fractional equations in future lessons. But get used to having restrictions on this. So let's start with the numerator, 5a minus 10. The common factor of 5a minus 10, you pull out a 5. And I'd rather do that in green because I'm trying to work out the solution here. So 5 times the quantity of a minus 2, because 5 times a is 5a, minus 5 times 2, that's minus 10. You have that all over the expression of a minus 2. Now between the numerator and denominator, you have a common a minus 2. So you factor those out, you just get 5. The answer is 5, but a cannot equal 2. That's your restriction. we have 4n plus 16 all over n plus 4. Well, we have a variable in the denominator. There is going to be a restriction. If we take the denominator of n plus 4, set that equal to 0, you're going to have n equal to -4, which means n cannot equal -4, because that would make the denominator 0 and make the expression undefined. So now let's factor out the numerator. 4n plus 16, there's a common 4 that factors out. You get 4 times the quantity of n plus 4. Then you get 4n plus 16 if you distribute that, all over the expression of n plus 4. Well, between the numerator and denominator, there's a common n plus 4. Those cancel out, you just get 4. You're left with 4 once you simplify this. Alright, let's see. We have 3n plus 1 all over 9n plus 3. Well, we need to find a restriction here because we have a variable in the denominator. You're going to take that 9n plus 3, set that equal to 0. So 9n would equal -3, n would equal -3/9 or -1/3, which actually n cannot equal -1/3, because if n equaled -1/3, you would have a denominator of 0, which would make the expression undefined. So that's your restriction. N cannot equal -1/3. So now, let's see here. We have the numerator of 3n plus 1. That doesn't factor any further. However, in the denominator, you have 9n plus 3. There's a common 3 that'll factor out. Then you get times 3n plus 1. Because then if you distribute the denominator, you get 9n plus 3. Well, between the numerator and denominator, there's a common 3n plus 1 that factors out. You do that, you're just left with 1/3. So when you simplify this, the answer is going to be 1/3. Alright, we have 8x minus 8y all over 8x plus 8y. Well, we have two variables. We got to figure out what would make the denominator equal to 0. Well, still, take your 8x plus 8y, set that equal to 0, so then 8x equals -8y, divide both by 8, you would have x equal to -y, and actually x cannot equal -y, because if x equaled -y, you would get a denominator of 0, making your expression undefined. So, now let's start with the numerator. Let's factor that out. 8x minus 8y, you have a common 8. That just leaves you with an x minus y in your, because if you distribute that, you would get 8x minus 8y all over. Then you have the denominator 8x plus 8y. There's a common 8 that factors out. Then you'd have the quantity of x plus y. Well, between the numerator and denominator, there's a common 8 that factors out, which is just going to leave you with x minus y all over x plus y. that would be the simplification of the fraction, would be x minus y all over x plus y. All right. So we have 2x minus 4 all over x squared minus 4. So now we have a quadratic in the denominator. Well, like you would any other expression with a variable, you're going to take that denominator, set that equal to 0. So take your x squared minus 4, set that equal to 0. You would factor that, you would get x plus 2 times the quantity of x minus 2 equal to 0. Well, x would be equal to negative 2 and would actually be plus or minus 2 because you'd have positive and negative 2 both. So that means x cannot equal either positive or negative 2 because that would give you a denominator of 0, which would make the expression undefined. So we don't want to do that. But let's start by factoring the numerator. You have 2x minus 4. There's a common 2 that factors out. You would have 2 times the quantity of x minus 2. You distribute that, you get 2x minus 4. All over the x squared minus 4, you would get x plus 2 times the quantity of x minus 2. Well, between the numerator and denominator, there's a common x minus 2 that factors out. So all you're left with is 2 over x plus 2. When you simplify the fraction, you get 2 over x plus 2 for your answer. We will talk more about restrictions in a future lesson, but for now, just get used to placing restrictions on the variable. Alright, you have 6y plus 30 all over y squared minus 25. So we got 6y plus 30 over y squared minus 25. Well, take your denominator, set that equal to 0. You'd get y squared minus 25 equal to 0, because we want to find restrictions. You factor the y squared minus 25, you get y plus 5 times the quantity of y minus 5. That'd be equal to 0. Take each of the factors, set them equal to 0, you get y equaling both plus and minus 5. Which means it cannot equal plus or minus 5, because if it equals either one, you're going to get a denominator of 0, making the expression undefined. So y cannot equal plus or minus 5. So now let's go through, factor out the numerator. 6y plus 30, there's a common 6 that factors out. You would get the quantity of y plus 5. All over, then you factor out your y squared minus 25, you would get y plus 5 times the quantity of y minus 5. Well, between the numerator and denominator, there's a common y plus 5 that'll factor out, so let's go ahead and do that. Once you simplify, all you're left with is 6 over y minus 5. That would be the answer, 6 over y minus 5. Alright, what's next? Let's see, we have 2xy over x squared y minus xy squared. So we got 2xy all over x squared y minus xy squared. Well, let's see here. Let's look for restrictions on the variable. take your denominator, set that equal to 0. You got x squared y minus xy squared equal to 0. Factor out your denominator. Factor this out, the least common denominator, or least common multiple of x squared y minus xy squared. You would get xy times the quantity of x minus y. Set that equal to 0. And then you would just end up getting xy equal to 0, which means neither x can equal 0, neither y can equal 0, because if either one's 0, the whole thing's 0, and then x cannot equal y. Because if x equals y, you also get a denominator of 0. So what you have now, you have your restrictions. X cannot equal 0, y cannot equal 0, x can't equal y. So now let's go ahead and go through and factor this here to simplify. 2xy, there's nothing more we can do with that. That's already simplified. But we've already done the factorization over here of x squared y minus xy squared. You get the quantity of xy times the quantity of x minus y. Well, between numerator and denominator, there's a common xy that factors out. So in the end, you're just left with 2 over x minus y. And that would be the simplification of the fraction. It'd be 2 over x minus y. Alright, let's see. We have 4p squared minus 8p all over 4p to the third. Alright, well first let's look for a restriction on this. Take your denominator of 4p to the third, set that equal to 0. Well, p just can't equal 0. If p equals 0, you get a denominator of 0, which makes the expression undefined. Now, let's go ahead here, factor out the numerator. We have 4p squared minus 8p. There's a common 4p between the 4p squared minus 8p. So then you would get 4p times the quantity of p minus 2. And if you distribute that, you would get 4p squared minus 8p. Now, you have 4p times the quantity of p minus 2 all over 4p to the third. Well, between the numerator and denominator, definitely the 4's are common. The 4's will cancel out. But you have p in the numerator, p the third in the denominator. If you factor out the common p, what you're left with is the quantity of p minus 2 over p to the second. And that's really as far as you can go with factoring this. You would get p minus 2 over p to the second. Alright, this one's already factored. You have the quantity of x plus 4 times the quantity of 2x plus 1 all over the quantity of 2x plus 1 times the quantity of x minus 3. Well, first, again, look for restrictions on your variables that would make the expression undefined. You would take the 2x plus 1, set that equal to 0. So then 2x would equal -1, x would equal -1/2, which means x cannot equal -1/2, because if it equals -1/2, you have 0 in the denominator. Then take your x minus 3, set that equal to 0. That would have x equal to 3, which means it can't equal 3, because if x equals 3, you also have a 0 in the denominator, making the expression undefined. So x cannot equal -1/2 or 3. Those would make the expression undefined. Even though it's plain to see we can factor out a common 2x plus 1 between the numerator and denominator, you still have to go by the restrictions of the original expression, not the factored out expression. You have to go by the restrictions of the original expression. So if we factor out the common 2x plus 1 between the numerator and denominator, you're simply left with x plus 4 all over x minus 3. And that would be your answer for when you simplify this. You would get x plus 4 all over x minus 3. Alright. We have x minus 5 times the quantity of 7x plus 2 all over the quantity of, now we have 5 minus x times the quantity of 7x plus 2. Alright, well, first set restrictions on your variables before you do any factoring and simplifying. Take that 5 minus x, set that equal to 0. That would just give you x equal to 5, which means x cannot equal 5, because if it does, you get a denominator of 0, making it undefined. Next, take your 7x plus 2, set that equal to 0. That means 7x is equal to -2. Then x would be equal to -2/7, which means that x cannot equal -2/7, because if it does, you also get a denominator of 0, making the expression undefined. So x cannot equal 5 or -2/7. Now, here's what we're going to do. It's plain to see at first that we have a 7x plus 2 in the numerator and denominator that'll factor out. So let's go ahead and do that. You're left with x minus 5 all over 5 minus x. They look similar but different. They are different. 5 minus x, you can factor out a common -1. You would have x minus 5 all over -1 times the quantity. Well, you do that, you would get positive x minus 5. You distribute that, you would get -x plus positive 5, which is 5 minus x. Well, now it's plain to see we have an x minus 5 in the numerator and denominator that'll factor out. So all you're left with is 1 over -1, or just simply -1. So the simplification of this is going to be -1. It's important to be able to recognize the negative of expressions too, and be able to factor those out, like we just did. Alright. We have a squared plus 8a plus 16 all over 16 minus a squared. Well, again, let's go ahead and place restrictions on the variable here first. Take your 16 minus a squared, set that equal to 0. The factorization would be 4 plus a times the quantity of 4 minus a, those equal to 0. Well, a just cannot equal plus or minus 4. If a equals plus or minus 4, you get a 0 in the denominator, making the expression undefined. So now we found our restrictions. Let's go ahead here and deal with the numerator and the denominator. First, deal with the numerator. We have 8a squared plus 8a plus 16. Well, this is plain to see that it's a trinomial, perfect square trinomial, which means this factors into a plus 4 to the second power. Then you do that expansion, you would get a squared plus 8a plus 16. So you have a plus 4 to the second power. Now, 16 minus a squared, we'd like to have the variable first. So we can factor out a negative 1. You do that, you would factor out your negative, you would get a squared minus 16. Then distribute that, you get negative a squared plus 16, which is the same as 16 minus a squared. Well, first let's go ahead and move the negative to the numerator. We can definitely do that. Since it's in the denominator, you would get negative a plus 4 to the second power. Alright, now a squared minus 16 factors into a plus 4 times the quantity of a minus 4. Well, plain to see there's a common a plus 4 that factors out. If we do that, you still have an a plus, you have a negative times the quantity of a plus 4 in the numerator. It's gone in the denominator, but you have a minus 4 in the denominator. For one more time to simplify this, well, you don't really need to distribute the negative. You just get negative a minus 4. So that's really as simplified as it's going to be. You would just get the negative times the quantity of a plus 4 all over a minus 4. That would be the simplification of this fraction. Alright, let's see. We have 25 minus b squared all over the quantity of b squared plus 12b plus 35. Alright, so we got 25 minus b squared all over the quantity of b squared plus 12b plus 35. Well, first take your denominator, set that equal to 0. So you take b squared plus 12b plus your 35, set that equal to 0. We need to factor this. You would get the quantity of b plus 5 times the quantity of b plus 7, set equal to 0. That means b cannot equal negative 5 or negative 7. If b equals either one of those, negative 5 or negative 7, you get a 0 in the denominator, therefore rendering the expression undefined. So now, let's go ahead here. Let's deal with a numerator. First, we have 25 minus b squared. Well, we always like to put the variable first, so you could factor out a negative 1. If you did that, you would get b squared minus 25. Then you distribute the negative, you get negative b squared plus 25, which is the same as 25 minus b squared. Do that. Now over here we factored out the b squared plus 12b plus 35. That'll be times the quantity of b plus 5 times the quantity of b plus 7 in the denominator. Well, we can definitely factor out b squared minus 25 further. You get negative of the quantity of b plus 5 times negative of the quantity of b minus 5 all over the quantity of b plus 5 times the quantity of b plus 7. Well, plain to see in the numerator and denominator, b plus 5 factors out. You're going to be left with a negative of b minus 5 all over b plus 7. And if you want to distribute that negative in the numerator, you can leave the negative. That would be one acceptable answer. Or you can distribute the negative. You would get 5 minus b all over b plus 7. Either way, you can do either method. So your simplification would be the negative of the quantity of b minus 5 over b plus 7. Or you could have 5 minus b over b plus 7. You can write it either way. Alright, let's see here. We have 2 minus y over y squared minus 4y plus 4. So we got 2 minus y over y squared minus 4y plus 4. Well, let's take a look at the denominator, set that equal to 0. You get y squared minus 4y plus 4. Set that equal to 0. Well, y squared minus 4y plus 4, that's the same as y minus 2, that quantity to the second power, equal to 0. Which just means y cannot equal 2. If y equals 2, you get a denominator of 0, therefore rendering the expression undefined. So, now let's start factoring. You have 2 minus y. We can factor out a negative 1, which would actually give you the quantity of y minus 2, because if you distribute the negative, you get negative y plus 2y. It's the same as 2 minus y. Now we have the factorization of this here. That was y minus 2 to the second power. Well, between the numerator and the denominator, there's a common y minus 2 that factors out. The numerator, you would just be left with negative 1 all over y minus 2. And that really would be your answer, is negative 1 over y minus 2. That would be your factorization. Alright. We have a minus 5 to the second power all over 25 minus a squared. Well, I would first take your denominator of 25 minus a squared, set that equal to 0. We factor out the difference of squares, you get the quantity of 5 plus a times the quantity of 5 minus a. Both of those equal to 0. In the end, a just cannot equal positive or negative 5, based on saying each of those factors equal to 0. Because if a equals either plus or minus 5, your denominator becomes 0, rendering this useless, rendering it undefined. So now let's start factoring here. you have a minus 5, that quantity squared. Well, right now we can't do anything with that. That's as factors as that's going to get. But you have 25 minus a squared. We can pull out a negative 1, which would give you a squared minus 25 in the denominator, negative of the quantity of a squared minus 25. Well, the a squared minus 25 definitely factors out. First, let's move that negative sign to the numerator. It's always good to get it out of the denominator. Let's see, you'd have negative of the quantity of a minus 5 squared over, then you have a squared minus 25. That gives you a plus 5. That quantity times a minus 5. Well, plain to see there's a common a minus 5 between the numerator and denominator. If you pull those out, you would get negative of the quantity of a minus 5. A minus 5 goes away in the denominator. You'd have negative of the quantity of a minus 5 all over a plus 5. That's one answer you can leave it as. Or you can write it as, if you distribute the negative sign, you would get 5 minus a all over a plus 5. That would be the simplification for this fraction. 5 minus a all over a plus 5. Alright, see how many more I'm going to do here. Alright, let's see. We have 2n squared minus 5n minus 3 all over 4n squared minus 8n minus 5. Alright, so we got 2n squared minus 5n minus 3 all over 4n squared minus 8n minus 5. Well, let's take the denominator, set that equal to 0. You would get 4n squared minus 8n minus 5. Set that equal to 0. Well, we need to factor this first, so we'll take n, then you'd have your 4n. Alright, looks like we're going to have a 5 here and a 1 here. Set that equal to 0, so let's see, 4n squared Well, that was the wrong factorization. Hold on here. So as I said, sometimes it's trial and error. You would have 2n times the quantity of 2n. You have a 5 and a 1. Yeah, that makes more sense. So you'd have 4n squared minus 10n plus 2n. Yep, that would give you negative 8n, then minus 5. Okay. So the factorization is 2n plus 1, that quantity, times 2n minus 5. Now just take each of your factors, set them equal to 0. 2n plus 1 equals 0. Well, then 2n would equal negative 1. That means n cannot equal negative 1/2. Then you have 2n minus 5 equals 0. Well, 2n equals 5. Which means n cannot equal 5/2. So if n equals either negative 1/2 or positive 5/2, the denominator goes to 0, therefore making the expression undefined. So now we have our restrictions. Now we can go ahead and factor the numerator and denominator. Let's factor 2n squared minus 5n minus 3. So let's see, you'll have n, then you'll have 2n, 3 would go here, 1 would go here. Alright, so let's see, 2n squared plus n minus 6n. Yep, that'll give you negative 5n minus 3. Okay, so the factorization of the numerator is n minus 3 times the quantity of 2n plus 1 all over. We've done the factorization for this one here in the denominator. You would get 2n plus 1, that quantity, times 2n minus 5. Well, between the numerator and denominator, there's a common 2n plus 1 that factors out. So once you simplify this, you would be left with n minus 3 all over 2n minus 5. And that would be your answer for this, would be n minus 3 all over 2n minus 5. Alright. I think we could do 2 more. We'll do 2 more, then we'll be done. So let's see, 2y squared minus 9y plus 4 all over 8y minus 2y squared. Well, what we have to do here, take your denominator of that 8y minus 2y squared, set that equal to 0. We can take out a negative 1, divide both sides by negative 1, you would end up getting 2y squared minus 8y. Set that equal to 0. So let's see, factor out a common 2y, that'd be times the quantity of y minus 4 equal to 0. Well, let's see, 2y equal to 0, that means y cannot equal 0. Then you have y minus 4 equal to 0. That means y cannot equal 4. So y cannot equal 0 or 4, because if it does, you end up having a 0 denominator, therefore rendering the expression undefined. So now let's go ahead, factor out the numerator. Let's see, you're going to have y times the quantity of 2y should be 2 and no, it won't be 2, it'll be 1 and 4. We'll have 4 and 1. Should get 2y squared minus y minus 8y is minus 9y minus plus 4. Okay. So you get y minus 4 times the quantity of 2y minus 1 for your numerator all over the quantity, the negative quantity of 2y times y minus 4. Well, it's clear to see that between the numerator and denominator, y minus 4 factors out. So let's move the negative sign to the numerator. You get negative of the quantity of 2y minus 1 all over 2y, which if you distribute the negative sign, you would end up getting 1 minus 2y all over 2y. So the simplification of this fraction would be 1 minus 2y all over 2y. Alright, one more here. Let's see, we have r squared minus s squared all over 4r squared plus rs minus 5s squared. Alright, so we got r squared minus s squared all over 4r squared plus rs minus 5s squared. Well, first let's take our denominator, set that equal to 0. You would have 4r squared plus rs minus 5s squared equal to 0. Let's go ahead and factor this, set the factors equal to 0. I'm going to say r and 4r. One and 5 for those. So let's see, 4r squared plus, actually that'd be s, 5s. rs and I forgot the s, my bad. So you get, let's see, 4r squared plus 5rs minus 4rs, which would give you positive rs minus 5s squared. So it looks like the factorization is going to be r minus s times the quantity of 4r plus 5s. So let's see, we'd have r minus s equal to 0, which means r cannot equal s. If r equals s, you get you'll end up getting 0 for your denominator, therefore rendering it useless, having a 0 denominator. Let's see, 4r plus 5s equals 0. So let's see, 4r equals negative 5s. R equals negative 5/4 s. So r also cannot equal negative 5/4 s. That would be another one that would render the expression undefined by having a 0 denominator. So we got our restrictions here now. Now we can go through, factor out the numerator and denominator. Factor out the numerator of r squared minus s squared, you get r plus s times the quantity of r minus s all over, we did the factorization over here, you get the quantity of r minus s times 4r plus 5s. Well, we can see between the numerator and denominator there's a common r minus s that'll factor out, leaving you with r plus s in the numerator all over 4r plus 5s in the denominator. And there's no further way to factor these, so the simplification is therefore r plus s all over 4r plus 5s. And that's it for this lesson. Next lesson we're going to multiply algebraic fractions. We're going to take it a little bit further. So I hope everyone has a good night. Take care.